This is TSR Math Mentor. Today I am here to explain about 10th mathematics topics which are useful for both the Telugu states, Telangana and Andhra Pradesh. Here actually we have 14 chapters for the public examination. Among them the first chapter is real numbers. So today we are going to discuss about real numbers related topics. So in these real numbers we have 5 different exercises. Means 5 different concepts we have to explain detailedly which are related to each individual exercise, right? So now before going to discuss about those 5 exercises, let us come to know the basic knowledge about natural numbers. Natural numbers are denoted by capital letters and it is equal to set of 1 comma 2 comma 3 comma 4 comma and so on up to infinite values. After that, if you include 0 to this one, to these natural numbers, if you include 0, it gives us new set which is called as whole numbers, denoted by the first letter W. To these values 0, 1, 2, 3 and so on up to infinite values, whole numbers, if you include negative naturals such as -1, -2, -3, comma and so on, you will get a new set. This set is called as integers. Integers. These are represented by the letter I or the capital letter Z. I is the first letter of integers like the previous. Z represents a German word Zahlen will be utilized to represent these numbers. Zahlen word's first letter is Z, that's why integers can be represented with either I or Z. This is it. In this integers we have to observe the specifications of the individuals. What were they? 0 is the neutral value. To this left we are having negatives. To the left we will get positives on the real number line as usual, everybody knows. So if you observe this one, these are called negative integers. These are called positive integers. So specially we can write them as negative integers. You can write them with Z minus, negative integer Z minus equal to set of and so on, -3, -2, -1. Likewise positive integers represented with Z plus or I plus, which is equal to set of 1 comma 2 comma 3 comma and so on, right? Along with this you can take 0 to positives. These are called non-negative. These are called non-negative integers. That is equal to set of 0 comma 1 comma 2 comma 3 comma 4 comma and so on. And another one is from 0 to back. These are called non-positive integers, which is equal to set of and so on, -3, -2, -1, 0. So you can write these negative integers as Z plus union singleton 0. Sorry, Z minus union singleton 0, and this can be taken as Z plus union singleton 0. Okay na? And if you observe, positive integers is nothing but set of 1, 2, 3 and so on, which is nothing but natural numbers. So this is nothing but n. Whereas the non-negative integers, non-negative, other than negative, means maybe 0 or positive. Most of the students will get a little bit confusion. Non-negative means they will fix for positive, which is wrong. Non-negative means other than negative means 0 neutral value will also be included to the positives. Along with 0, positive values we have to take. That's why non-negative integers represented with set, and this representation will also be allowed, and it is nothing but W, whole numbers. So these two, negative integers, positive integers, has to be remembered very carefully, because in most of the chapters consideration of the values from the negative integers, from the positive integers specifically they will tell. So remember them. Along with that, what is non-negative integers? Don't confuse, 0 will be there with positives. Non-positives means other than positive. To the negatives, 0 will also be included. Remember them. After this, along with the previous integers, we have to discuss the next number sets, that is rational numbers. Rational numbers are represented with Q, not with its first letter R. It is taking Q, because rational number general forms are set of P by Q. Set of P by Q such that P comma Q are integers, previous set integers, where Q is not equal to 0. So division is the representation of this one. In that division, 7 by 2, its answer is 3.5. This is, you will get generally in the quotient form. 2 times 3 is 6, 1, decimal point 10 will become 2 5s are 10, remainder 0. 7 by 2 is the division form, P by Q form. Its answer is 3.5, which is nothing but quotient. So rational numbers are represented with P by Q form, where P comma Q are integers, Q not equal to 0, denominator should not be 0. It gives the quotient value. That's why representation of this one will be taken with Q. Clear? Right. So along with this, the next one is irrationals. The numbers which are not rationals, which cannot be written in the form of P by Q, those are called irrationals. Generally, we will see most of the English words, regular, opposite is irregular. Responsible, opposite is irresponsible. Like that, rational, opposite set, composite set gives you irrational numbers. Clear? So that's why its composition will be represented with Q dash, but it can be represented with nth root of A having n individuality, A individuality, such as n is a natural number which is greater than or equal to 2, and A is a positive rational. A is a positive rational which cannot be written as the nth power of any other rational number. But that one we have to remember, that's it. So it is, here it is a little bit difficult to write. So A is a positive integer which cannot be written as nth power of any other rational. You know why? Let us take an example. Cubed root of 9. Cubed root of 9. Here n is 3, which is a natural number greater than 2. A value is 9. A value is 9, positive integer, which cannot be written as nth power of any other rational number. 9 can be written as some rational whole square, but 9 can be written as whole cube of any other rational number value. We cannot write this one. We cannot write. So that's why cubed root of 9 will become irrational, whereas cubed root of 27 if you see, or cubed root of 8 if you have taken, n is 3 natural number greater than or equal to 2, A is a positive rational number, and this A 8th value can be written as cubed root of some other rational. 8 can be written as cubed root of some other rational. By this, cubed root of will become whole power 1 by 3. 8 can be written as 2 cube. Then a power m whole power n will become a power m into n. By that, they get cancelled. It gives you 2 power 1, which is equal to 2. Even though it look like nth root of a form, because of that a representation, it is getting cancelled with its cubed root and it is giving us rational value. Understood? So that is the special condition, and in detail we will discuss about its condition later on. So after the rational numbers and irrational numbers discussion, we will take real numbers, which is our first chapter name. Real numbers. Real number is represented with its first letter R. It is nothing but rational union irrational. Rational union irrational gives us real numbers. It means both the rational numbers which can be written as p by q form and which cannot be written in this p by q form irrationals, both can be called as real values. We will get them really, practically we will get them. We can get them on the number line. That's why its name is real numbers, represented with its first letter R, which is equal to q union q dash. Is that clear? Now we entered into the real numbers topic, right? So now in this topic real numbers, we have 5 exercises based upon 5 different concepts. First exercise is depends upon Euclid's division lemma or Euclid's division algorithm. So what is Euclid's division algorithm? Explains us. In the earlier classes already we know the long division process. For example, if 9 wants to divide with 4, so we will do the process as 9 as the dividend and 4 as the divisor. Automatically 4 times 2 gives you 8. Division is nothing but continuous subtraction, so subtraction will go on and it remains 1 as the remainder. So if 9 is the 4 is the divisor, related to them we will get another unique pair of numbers 2 and 1, 2 as the quotient, r as the remainder, where 9 is the dividend and 4 as the divisor, right? So here this process is completely depends upon Euclid's division lemma. So the famous Greek mathematician Euclid, in his famous books The Elements, 7th book contains Euclid's division lemma and Euclid division algorithm. Based upon that only, unknowingly we are doing this long division process. What this Euclid's division lemma explains? Euclid's division lemma explains what? If a comma b are any two positive integers, that's why I explained that one. Any two positive integers, related to them you will get another unique pair of whole numbers q comma r, such that dividend a is equal to b times q divisor into quotient plus remainder. Got it? Dividend is equal to divisor into quotient plus remainder. Let us observe this one. Here dividend 9 is equal to divisor into quotient 4 times 2 plus remainder 1. Correct? 4 times 2 8 plus 1 is 9. So this is clearly Euclid's division lemma, where a is equal to b into q plus r, dividend equal to divisor into quotient plus r, where r is having its own speciality, that remainder is always like this, 0 less than or equal to r less than b. This is the speciality and specification of real number remainder. We have to remember this one, because based on this only the exercise problems will be solved based upon that importance. Right. Coming to this here, the divisor is 4. So when any number is divided by 4, remainder possibilities are either 0 or 1 or 2 or 3. Only 4 chances will be there when any number is divided by 4. So starting with 0, 1, 2, 3, the whole numbers less than the divisor. If divisor is 7, remainder is having 7 chances, such as 0, 1, 2, 3, 4, 5, 6, 7 chances. So that importance will be represented with 0 less than or equal to or less than b. This is called Euclid division lemma. Right. Using this, what we will do? So by applying this kind of division lemma multiple times, we can find out the HCF of any two given numbers. HCF of any two given numbers. The process of applying Euclid division lemma to find out the HCF of any two numbers step by step is called algorithm. That's why Euclid's division algorithm will be utilized to find out the HCF of any two given positive integers. Right. Right. As I told you before, using Euclid division lemma or its multiple times repetition Euclid division algorithm, you can find out HCF of any two positive integers. Right. So based upon that, we will be having exercise 1.1 based upon Euclid division lemma. So in this, 5 problems are there. Among them, most important problems are, for the examination point of view, first bit, first problem, and second one, third one, fourth one. These are the important problems. Right. So what that first bit contains? They are telling use Euclid's algorithm to find out the HCF of the following two numbers. Use Euclid's division algorithm to find out the HCF of the following numbers. In this, the first problem is given as 900 and 270 are the two positive integers. How to find out the HCF? Actually known process only. Already I told you na, take the long division. 270 is the divisor dividing 900. Then 270 times 3 is equal to 3 zeros are 0, 3 sevens are 21, 3 twos are 6, 8. It is 8, 10. So by the subtraction, it will become 0, 90. So when the remainder is 90, non-zero, again this is going to divide the previous divisor. If remainder is not 0, the remainder is going to divide the previous divisor. So again, second step of division will start. So second step of division, 90 is dividing 270. Okay, now 90 times 3 is exactly 270, therefore the remainder is 0. Since the remainder is 0, the final divisor which gives the remainder 0, that is called final divisor, that will become the HCF. That will become the HCF. So HCF here is 90. So we have calculated this one by using long division. This concept is there in the 8th state. Okay, but we have to write that one in the theoretical matter using Euclid division lemma and Euclid division algorithm. So for that one, how to start the solution? Let a is equal to the first number, big number 900, comma b is equal to 270 be the divisor. Apply Euclid's division lemma as a is equal to this one by using long division. This concept is there in the 8th state. Okay, but we have to write that one in the theoretical matter using Euclid division lemma and Euclid division algorithm. So for that one, how to start the solution? Let a is equal to the first number, big number 900, comma b is equal to 270 be the divisor. Apply Euclid's division lemma as a is equal to b into q plus r, where 0 less than or equal to r less than b, right? So by this, first step gives you 900 is equal to, b is the divisor, 270 into 900 is equal to 270 into 3 plus remainder 90. Clear? Now since the remainder are equal to 90, which is not equal to 0, again apply the Euclid's division lemma between 90 and 270. Between 90 and 270. As like this, bigger number is a, smaller number will become b. By this, using the second step, 270 will be equal to divisor 90 into quotient 3 plus 0. Since the remainder are equal to 0, comma, the HCF of 900 comma 270 will be equal to 90, final divisor 90. This is the way of finding HCF of any two given positive integers. So in this, number of times will be increased until we will get the remainder 0. The divisor who will give the remainder 0 will become the HCF. Got it? So now in this process, one more logical point is there. To these two numbers 90 and 270, we got the HCF as 90. Not only for that, for 270 and 90 also HCF will become 90. Okay, so like that, if multiple steps are increased, that pair in the form of dividend and divisor will be having same HCF. That we have to remember.